Hi, Geometry Scholars. Here we are. We're in Chapter 7, Lesson 4, Properties of Special Parallelograms. So these three in particular have some special properties. We're going to start with the definitions. Then we're going to do 3 corollaries, and we're going to do 3 theorems. So hold on your hats. I know it's exciting. We're going to start with the core vocabulary of rhombus, rectangle, and square. This is what we're going to learn in these next 15 minutes. We're going to use those properties of special parallelograms. We're going to use properties of diagonals of special parallelograms. They're pretty exciting. And then in a perfect world, we will also use coordinate geometry to identify these special types. So without further ado, let's do our vocabulary. We're going to start with the core concepts of rhombuses, rectangles, and squares. So again, definition. A rhombus is a parallelogram with 4 congruent sides. I like to think of it as a squished square because they're all the same. A rectangle is a parallelogram with 4 right angles. 1, 2, 3, 4. And then a square is a parallelogram with 4 congruent sides and 4 right angles. So it's this and this that is the special case, sort of like equilateral and equiangular. That's why that makes this a regular convex polygon. And on we go. So we can use the corollaries below to prove that a quadrilateral is a rhombus or is a rectangle or is a square without first proving that the quadrilateral is a parallelogram. So first we've got the rhombus corollary. It's a rhombus if and only if it has 4 congruent sides. So you can see AB is congruent to BC, is congruent to CD, is congruent to AD. There is a proof. It's example 81 in your book if you want to see it. Corollary 7.3. A quadrilateral is a rectangle if and only if it has 4 right angles. Remember, if and only if means both ways. It's a quadrilateral. It's a rectangle if it's got 4 right angles, and if it's got 4 right angles, it is a rectangle. So it goes both ways, a bijection. And then a square corollary, a quadrilateral is a square if and only if it is both a rhombus and a rectangle. That's why it's both. So you now have 3 corollaries, which we are going to use those special properties. So this is a little map. It shows you a Venn diagram with some of the important relationships among these different vocabulary words, parallelograms, rhombuses, rectangles, and squares. So for example, you can see that a square is a rhombus because it's a parallelogram with 4 congruent sides. So a square is in this big rhombus circle. Because it has 4 right angles, it's also a rectangle. So it's in this nexus here where it's both a rectangle and a rhombus. But you can have a rectangle without it being a rhombus, that's here, or a rhombus without it being a rectangle. So, and then the parallelograms, the other ones, they're just hanging out there. It's a big deal. We're going to memorize that Venn diagram. Here we go. So the first thing we're going to do is we're going to take a look at the how we can use these properties to decide whether a statement is always or sometimes true.
For any rhombus QRST, decide whether the statement is always or sometimes true. Draw a diagram and explain your reasoning. Part A. Angle Q is congruent to angle S. Part B. Angle Q is congruent to angle R. Solution. Part A. By definition, a rhombus is a parallelogram with 4 congruent sides. By the parallelogram opposite angles theorem, opposite angles of a parallelogram are congruent. So, angle Q is congruent to angle S. The statement is always true. Part B. If rhombus QRST is a square, then all 4 angles are congruent right angles. So, angle Q is congruent to angle R when QRST is a square. Because not all rhombuses are also squares, the statement is sometimes true.
So you're going to have to be very careful with your definitions and be able to figure out which is which. Remember, if you can even find one example where whatever it is not the case, you can't say always true. It'll most often be sometimes. So it's easier sometimes to find an example where it's not true than it is to find, you can't find them always true. So that's a strategy. Here we go. Next, we're going to classify special quadrilaterals. Okay.
Classify the special quadrilateral. Explain your reasoning. Solution. The quadrilateral has 4 congruent sides. By the rhombus corollary, the quadrilateral is a rhombus. Because one of the angles is not a right angle, the rhombus cannot be a square.
That's it. So you have to figure out which one it is by the definition. Okay, so this is stuff we do together. Now, here's our diagonal theorems. Again, this will be in your notes, but they're pretty cool. They're kind of special, so listen to them here. So we've got 7.11. So first, if you have a rhombus, a parallelogram is a rhombus if and only if its diagonals are perpendicular. Before, we had parallelograms bisecting them, but now on the inside, they have to be perpendicular. So it's a rhombus if and only if AC is perpendicular to BD. We'll be looking at some slopes on that one. Also in the example, remember it shows that biconditionals such as the rhombus diagonals theorem can be written as 2 parts. And then to prove a biconditional, you have to prove both parts. You have to prove it the if then and then if. And that way it's both ways, biconditional. Theorem 7.12, rhombus opposite angles theorem. A parallelogram is a rhombus if and only if each diagonal bisects a pair of opposite angles. So you can see angle A and angle C are bisected because those are equal markings. And angle B and angle D are bisected because those are congruent markings. There are examples 73 and 74 in your book if you want to look at it. Otherwise, the proof is here as well. We're not going to go through it in this video, but we might in our class notes. And here is how we're going to use those properties to solve a problem. Find the measures of the numbered angles in rhombus ABCD.
Find the measures of the numbered angles in rhombus ABCD. Solution. Use the rhombus diagonals theorem and the rhombus opposite angles theorem to find the angle measures. First, to find the measure of angle 1, use the rhombus diagonals theorem. By this theorem, the diagonals of a rhombus are perpendicular. So, angle 1 is a right angle, and the measure of angle 1 equals 90 degrees. Next, to find the measure of angle 2, use the fact that opposite sides of rhombus ABCD are parallel. So segment AB is parallel to segment CD. Notice that angle 2 and the 61-degree angle are alternate interior angles. So, by the alternate interior angles theorem, these angles are congruent, and the measure of angle 2 equals 61 degrees. Now, to find the measure of angle 3, use the rhombus opposite angles theorem. By this theorem, each diagonal of a rhombus bisects a pair of opposite angles. So, angle 2 and angle 3 are congruent. The measure of angle 2 equals 61 degrees, so the measure of angle 3 equals 61 degrees. Finally, to find the measure of angle 4, use the Triangle Sum Theorem. By this theorem, the sum of the measures of the interior angles of a triangle is 180 degrees. So, the measure of angle 1 plus the measure of angle 3 plus the measure of angle 4 equals 180 degrees. Substitute 90 degrees for the measure of angle 1 and 61 degrees for the measure of angle 3. Now solve for the measure of angle 4. First, combine like terms on the left side of the equation to get the equation 151 degrees plus the measure of angle 4 equals 180 degrees. Then subtract 151 degrees from each side of the equation. This gives you the measure of angle 4 equals 29 degrees. So, the measure of angle 1 equals 90 degrees, the measure of angle 2 equals 61 degrees, the measure of angle 3 equals 61 degrees, and the measure of angle 4 equals 29 degrees.
So hopefully you can see how we use those corollaries, again, to solve problems. I believe at this point, we are going on to the next theorem. I told you there were 3 corollaries and 3 theorems. So this one is rectangles, diagonals. A parallelogram is a rectangle if and only if its diagonals are congruent. And the good thing about this is they look congruent. Okay, they look the same. So there are, again, proofs in your book, examples 87 and 88. We're not going to do that right now, but we know that a rectangle has both parallel sides, opposite, and then that makes AC congruent to BD, and you see that they're all bisected. So we're going to go through a real-life example, building out a frame for a window.
You are building a frame for a window. The window will be installed in the opening shown in the diagram. Part A. The opening must be a rectangle. Given the measurements in the diagram, can you assume that it is? Explain. Part B. You measure the diagonals of the opening. The diagonals are 54 and 8/10 inches and 55 and 3/10 inches. What can you conclude about the shape of the opening? Solution. Part A. No, you cannot assume that the opening is a rectangle. Recall that a rectangle is a parallelogram with 4 right angles. The boards on opposite sides are the same length, so they form a parallelogram. But you do not know whether the angles are right angles. Part B. By the rectangle diagonals theorem, the diagonals of a rectangle are congruent. The diagonals of the quadrilateral formed by the boards are not congruent, so the boards do not form a rectangle.
So even though it looks like it, you still have to be able to prove it. And we're going to do another example. This is where we have the lengths of the diagonals in a formula, like an equation. So if they're equal, you know what to do.
In rectangle QRST, QS equals 5x minus 31 and RT equals 2x plus 11. Find the lengths of the diagonals of QRST. Solution. By the rectangle diagonals theorem, the diagonals of a rectangle are congruent. Find x so that segment QS is congruent to segment RT. Set the diagonal lengths equal. So, QS equals RT. Then substitute 5x minus 31 for QS and 2x plus 11 for RT. Now solve for x. First, subtract 2x from each side of the equation. This gives you 3x minus 31 equals 11. Then add 31 to each side of the equation. This gives you 3x equals 42. Finally, divide each side of the equation by 3. This gives you x equals 14. When x equals 14, QS equals 5 times 14 minus 31, which equals 39, and RT equals 2 times 14 plus 11, which equals 39. So, each diagonal has a length of 39 units.
That's how you prove it. Show that they're the same. Use your algebra to solve an equation. And yeah, I think we're at the end of the notes for today. Oh no. Now, the coordinate geometry, I'm going to go ahead and put this example in here. I don't know if I'm going to actually test you on it, but might as well look through it.
Decide whether parallelogram ABCD with vertices A, -2, 6, B, 6, 8, C, 4, 0, and D, -4, -2 is a rectangle, a rhombus, or a square? Give all names that apply. Solution. Step 1. Understand the problem. You know the vertices of parallelogram ABCD. You need to identify the type of parallelogram. Step 2. Make a plan. Begin by graphing the vertices A -2, 6, B 6, 8, C 4, 0, and D -4, -2, and connecting them. From the graph, it appears that all four sides are congruent and there are no right angles. Check the lengths and slopes of the diagonals of parallelogram ABCD. If the diagonals are congruent, then parallelogram ABCD is a rectangle. If the diagonals are perpendicular, then parallelogram ABCD is a rhombus. If they are both congruent and perpendicular, then parallelogram ABCD is a rectangle, a rhombus, and a square. Step 3. Solve the problem. Use the distance formula to find AC and BD. AC is equal to the square root of the quantity -2 minus 4 squared plus the quantity 6 minus 0 squared, which equals the square root of 72, or 6 times the square root of 2. BD is equal to the square root of the quantity 6 minus -4 squared plus the quantity 8 minus -2 squared, which equals the square root of 200, or 10 times the square root of 2. Because 6 times the square root of 2 does not equal 10 times the square root of 2, the diagonals are not congruent. So, parallelogram ABCD is not a rectangle. Because it is not a rectangle, it also cannot be a square. Now use the slope formula to find the slopes of the diagonals AC and BD. The slope of segment AC is equal to the quantity 6 minus 0 divided by the quantity -2 minus 4, which equals 6 divided by -6, or -1. The slope of segment BD is equal to the quantity 8 minus -2 divided by the quantity 6 minus -4, which equals 10 divided by 10, or 1. Because the product of the slopes of the diagonals is -1, the diagonals are perpendicular. So, parallelogram ABCD is a rhombus. Step 4. Look back. Check the side lengths of parallelogram ABCD. Each side has a length of 2 times the square root of 17 units. So parallelogram ABCD is a rhombus. Then check the slopes of 2 consecutive sides. The slope of segment AB is equal to the quantity 8 minus 6 divided by the quantity 6 minus -2, which equals 2/8, or 1/4. The slope of segment BC is equal to the quantity 8 minus 0 divided by the quantity 6 minus 4, which equals 8 divided by 2, or 4. Because the product of these slopes is not -1, segment AB is not perpendicular to segment BC. So, angle ABC is not a right angle, and parallelogram ABCD cannot be a rectangle or a square.
So even though that last part, shows you with slopes that they can't be perpendicular, it's not 100% necessary because you already know with the diagonals corollary. So that's how you do one of those. As far as that goes, you will probably see it in your homework. I may or may not put it on a quiz. It will be fair game if I tell you. Otherwise, there are 91 exercises in this unit. That's why we're going to for sure take 2 definite days. We'll do class notes as well, and then we'll have a work day for you to ask questions. So I know it's a long video, and we'll do notes too. So re-watch any part you need. Stop, rewind, And don't forget to go over the vocabulary with the Quizlet.